All right, so now we're in section 4.5. Section 4.3 was really called OR and involved 3 circles. And section 4.4 was called and involved 1 circle. And section 4.5 is officially called conditional probability. But what it is this extra long line, kind of like an absolute value line or something like that. It's a really long line, it's not a 1. And it's pronounced given. Probability that I have a third girl, given that I already have 2. Okay, now in real life, we always think, well, they got 2 girls, they should have a boy this time just to kind of even up the numbers or something. Okay, or maybe, well, gosh, they have a lot of girls. They probably have a girl thing going. Maybe they'll have another one. We try and reason it through like that. Okay, but biology doesn't work that way. Biology doesn't care what you've had in the past. It's just going to do what it's going to do. The probability, given that you already have 2. So if you just know someone's pregnant, you say, oh, well, it's 50-50 on it being a girl there. And then they say, but I've already got 2 girls at home. They're giving you an extra piece of information. Okay, and in this case, because they're independent of events of each other, it doesn't matter that you got other kids at home. Okay, this is still 50-50. All right, so the word given means I'm going to give you some more information. All right, now, then they go off into this success and failure thing, so we'll do that, and we'll do more with the line in the next video. But I've got these 2 alarm clocks, and I really, really need to show up for a final. Okay, so I could just set just one of the alarm clocks. First of all, I should go out and buy a better alarm clock, because it's only got a 90% chance of working. All right, but I've decided I'm just going to make do with these 2 really faulty alarm clocks. If I set one alarm clock, what if it doesn't go off? There's like a 10% chance of my failing the class. Okay, so I set both alarm clocks. One of them's bound to go off, right? Well, it could be they both fail. They each have a 10% chance, so maybe they both fail. All right, that would be even worse. And then you think, well, I'm going to have to reason this whole thing through. Okay, the first one could be successful, and then the second one could fail. Or the first one could fail, but the second one would save me. Or, well, they could both be successful. So I got to work out all these weird, combinations of things for what could happen. Presumably they're independent of each other. These alarm clocks don't know what each other's doing, so I could probably multiply some stuff. But I'm going to have to do all these different multiplications for all these different possibilities. Or I could go with this. The probability of success is 1 minus the probability of failure. Okay, well, so, I just want 1 to go off. The thing I don't want is for 0 to go off. Okay, 1 can go off, 2 can go off, don't care which one. The one thing I don't want is that 0 of them work. So it might be easier to figure out what's the probability of 0 of them working. Okay, well, if the first one fails, well, that was like a 10% chance. If the second one fails, that's also a 10% chance. Okay, and if they both fail, they are independent of each other. Probability of 2 failures is, since they are independent, I could just multiply those. 0.1 times 0.1, 0.01. Okay, so I've now figured out the chance of me not showing up for the exam. Okay, they both have to fail for me to not show up for the exam. And then I want success. 1 minus the probability of failure. There's a 99% chance I'm going to actually make it to my final exam. So that's better, really, than just setting one of them. If I hadn't been reasoning this through, if I just gone, oh, well, why don't I just take 0.9 times 0.9, because I got 2 of them. Well, 0.9 times 0.9 is actually 0.81, and that would make my chances worse. If I use 2 clocks, it's worse than if I just use 1. That doesn't even make any sense. So at first I wanted to just multiply those together, but that would be the probability of them both working. And I don't need the probability of them both working. I need to know about the probability of them both failing. So that's how you would do this problem.